Next on the list of transformations are reflections. Reflections can be done in three ways, either over the x-axis, across the y-axis, or both. The origin, it's considered to be a reflection over both of those, but also considered to be reflected through the origin. So if it's across the x-axis, that's the simplest one. That's where you just put a negative out in front of the formula and it flips it vertically. If it's across the y-axis, you put a negative on every single x within the function itself. So you have to put a lot of negative x's in there. And then, but like I said before, if it's both of them, it's both negatives in there. So we'll go on to the example to see how that looks in this particular formula. So we've got an example of a function that's already in factored form. We see a graph of it right here, and we want to reflect this with in a number of different ways. If you've got your graphing calculator handy, it might be a good idea to actually try this and see if you notice those things going on, or maybe you are on the Desmos calculator, whatever works for you in that regard. First of all, let's reflect over the, well, I'm going to go in the order that we had it on the last one. For some reason I have this flipped around, but let's start here, the x-axis. That's the most basic one, and as I mentioned last time, that is just put a negative out in front of the f of x. So with this whole formula, it's just negative and then everything goes after it. If you punch that into your calculator with just the negative changed out in front, you should find that this flips it vertically. It flips it over the x-axis. Now, the little bit more complicated version is over the y-axis. That one, we have to include a negative x for every single spot that we see an x in this function. So what that means here is we've got x plus 2 inside there. I'm just going to go ahead and put extra set of parentheses to emphasize it. You don't have to do that when you're entering it in for your calculator if you're using your calculator. And I'm going to put an extra set of parentheses in for each one, again, just to emphasize that that's what's happening. And then I've got one more factor, but I have to put a negative x in for each one. You can test that out and see what it does on your calculator. You should find that it flips it horizontally over the y-axis. If I want to do both, it's going to look kind of like a 180-degree rotation through the origin. And so if I want to do both, I just have to combine everything. So it's going to be negative f of negative x, and that means the negative will be out in front for one thing, and then we also plug in negative x for every spot that I see an x in this equation. So it becomes a little bit redundant, but it is important to put all those negatives in there if we're going to accurately represent all the different transformations.